All right, welcome back, people. My name's Todd McLeod. You're in statistics, and we're going into module number 5 here. And in module number 5, we're going to learn all about this information right here. So you can see that. And we're going to start out with random variables. And to understand random variables, we're going to go to ChatGPT. And we're going to ask ChatGPT, please explain coding schemes to me and use both Morse code and binary and ASCII to illustrate this in particular showing how ASCII can map circuits in on-off states to letters of the alphabet. Thank you. All right, so we're going to learn about coding schemes here. Understanding coding schemes. So coding schemes are methods used to represent data such as letters, numbers, or symbols, or colors, or sounds in a way that can be easily processed, stored, or transmitted by computers and communication systems. These schemes map characters to specific binary sequences. Processed, stored, or transmitted by computers and communication systems. Coding schemes map characters to specific binary sequences, a series of zeros and ones, or circuits. Zeros and ones are actually coding schemes to represent circuits in on-off states. Two common coding schemes are Morse code and ASCII. And so Morse code is a coding scheme. And the way Morse code works is it could be like da-da-da-da-da-da-da-da-da. It could be sounds, where long and short are the two different sound types. Or it could be lights, right, where you flash lights, where the lights are long and short flashes, and then somebody keeps track of how many longs, how many shorts, whether they're sounds or lights, and based upon the longs and the shorts, these longs and shorts, right, when they're transmitted either by sound or by light, so if you have a short and a long, that translates to the letter A in this coding scheme right here, and it's called a coding scheme because it's a scheme for coding short and long pulses, whether they're lights or sounds, to letters. And so that's a coding scheme. And another coding scheme is like with computers. Everything in computers, computers run on electricity. Electricity can be on or off. And you have circuits or switches in on-off states inside computers. This is just all FYI, interesting to know, helping you learn about coding schemes. But computers run on electricity, and electricity can be on or off, and computers have circuits or switches in on-off states, and those on-off states are representative of something. So just like your porch light on Halloween has a switch, a light switch, which is in an on-off state, and that light switch has a coding scheme on October 31st on Halloween. And so the coding scheme for that light switch on your porch on Halloween is if the light switch is on, it means come trick or treat, and if the light switch is off, it means go away. That's a coding scheme. Well, in computers, you have you have billions and billions and billions of little switches, right? Which could be in on-off states, just like your porch light on Halloween. These switches can be in on-off states, and sometimes they're called switches, sometimes they're called circuits, sometimes they're called transistors. All those words are interchangeable. But whether or not a circuit or a switch is in an on-off state, 1 represents on and 0 represents off, which is why the power symbol, just interestingly, right, is a combination of 0 and 1, because 0 means off and 1 means on, and this is the button you push to turn it on or off. So that's how the power symbol came into being. But if you have, these circuits or these switches, you have what, 7 of them? And if these 7 in this coding scheme here are in the state of on, off, 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 on, you're going to have the letter A being stored. And so here's this idea of coding schemes where we could have one thing representing something else, right? So we could have short and long dashes, whether it's light or sound, represent letters of the alphabet, or we could have ones or zeros, which represent on or off states. We could have those on or off states represent letters of the alphabet, depending upon the coding scheme. And we get to determine what the coding scheme is, right? So when computers were created, people determined, hey, this arrangement of on-off switches and on-off states represents this letter. This other arrangement here of switches and on-off states represents this letter. This arrangement here of switches and on-off states represents this letter. And that's just the coding scheme they created. And so you're learning about this because the first thing we're going to learn about here are random variables. And in many ways, when I learned about random variables in statistics, I thought, hey, this is like a coding scheme. Because what a random variable does is it's a numerical description of the outcome of an experiment. So there it is. A random variable is a numerical description of the outcome of an experiment. And so we're going to come back over to ChatGPT, and we're just going to like capture the slide. So we could go down to File, and we could go down to Download, and we're going to download this as a, I don't know, we'll go with PNG this time. So PNG and JPG are two different coding schemes. And I'm going to rename my chat here. I'm going to rename this one, and I'm going to call this chat Module 5 Statistics. And then I'm going to come back over to my downloads. That's not my downloads. That's my recording. And, and I'm going to go to my downloads. And I just want to have a good time. You know, if I'm going to be up past 10 talking about statistics, it's got to be at least somewhat entertaining. And I'm going to come here, and I'm going to say, can you please explain random variables? Can you please explain random variables in statistics to me? And also provide me with an example, and if applicable, connect this concept of random variables in statistics. We'll take that out. Why not? To coding schemes, e.g. the way a random variable is a numerical description of an outcome. And we'll put it e.g. the way a random variable is a numerical description of the outcome of an experiment, right? So, you know, you have a variable like 0 or 1 or 2 or 3 or 4 or 5 represents something, whether that, numeric variable or arrangement of them is representing A or B, or the numeric variable is, or we have like dashes and dashes, longs and shorts, dashes and dots representing A or B or C. Right now we have a numerical variable representing some outcome. So 0 could represent success, 1 could represent, or we'll say 0 represents failure, 1 represents success. It's a random variable. All right, so we'll have it explain it. And the reason we want to like start doing that is because by having, this is just Todd McLeod's take on why statisticians decided to include random variables, is because then you could start to do other stuff with it, and you could like think about it. It's a framework for thinking about things and thinking about problems, that are more complex, and to simplify the way you're thinking about those more complex problems. And so it's a framework for just thinking about different situations. So that's why we're learning about it. We're learning about another framework for thinking about different situations, which could sometimes be very complex. And it helps us think about that complexity in a way that, simplifies it. That's the goal. Let's make it simple. So now we'll see what ChatGPT says about random variables in statistics. And I really like ChatGPT because I feel like it simplifies things. And you could keep asking it questions, whereas with your textbook, sometimes, pretty regularly in the textbook we're using, I feel like it's kind of complex and convoluted, and ChatGPT makes it a little bit more simple. A random variable is a fundamental concept in statistics representing a numerical description of the outcomes of a random phenomena or experiment. So it represents a numerical description of the outcomes of a random phenomena or experiment. So random meaning the outcome is going to be random. You don't know what the outcome is going to be. And so random variable is a fundamental concept in statistics, and it represents a numerical description of the outcomes of a random phenomena or experiment. So you have a variable representing the outcome of a random phenomena or experiment. So it's not like the variable's random. The variable's representing the outcome of some experiment where, it's random what the outcome's going to be. Essentially, it assigns a numerical value to each possible outcome of an event. I like this description better. It assigns a numerical value to each possible outcome of an event. So if you remember what we learned in the previous chapter, we were talking about a sample space, right? And then that sample space has, as the subset, it has an event. And the event is a subset of the sample space. And the sample space has sample points. And let me find that picture just so we can review it, keep it fresh in our minds. Hold on one second. Okay, welcome back. And here is that slide. So we have an experiment. And an experiment will have outcomes. And then the sample space is all of the outcomes in an experiment. And you know, that are possible for an experiment. Like these are all the possible outcomes, like all the possible outcomes. And each possible outcome is a sample point. So sample space is made up of all the sample points or all of the outcomes that are possible from an experiment. And then an event is a subset of the sample space, and that subset could be all of the sample space. And so if we come back over here and we take a look at ChatGPT, it assigns a numerical value to each possible outcome of an event. So I really like that. And there are two main types of random variables. There's discrete and there are continuous random variables. And so in our slides here, you can see we have discrete and we have continuous. And so discrete random variable, discrete just means it's going to be a constant number. Discrete is like the number of people, right? Like you're going to have 1, 2, 3, 4, 5, 7, 42, 179. You're not going to have fractions of a person. But a continuous random variable is like temperature or speed or distance, right? You could have like, you know, it's 6 feet and 4 inches and then fractions of an inch after that, right? It's continuous. It could go on forever. It's like pi. There's no end to it. And so that's the difference between discrete and continuous. So the variables that we create to represent an outcome of an event can be discrete, and it could take on, you know, a discrete number, so 0, 1, 2, 3, and that could be finite or infinite. And so finite would be like, you know, there's like, you know, 4 sections to the test. That's 1, 2, 3, 4. It's finite, right? And you know, there's just, or there's like 4 flavors you could choose from at our ice cream shop. That's finite. Infinite is like how many people have passed through this toll booth. Like that could just keep going and going and going. There potentially is no stop to that. And so that would be infinite. So we have discrete finite and we have discrete infinite. And you can see that here in this slide. A random variable is a numerical description of the outcome of an experiment. And there's a discrete random variable, which can be either finite or infinite. And then there's also a continuous random variable. So continuous is it like height, weight, speed, you know, money. I think money would be continuous. You could have like, you know, if it's Bitcoin, you have all kinds of little fractions all the way down. You keep shaving that over and over and over and making it decimal. So continuous random variable can take on any value within a certain interval or range. The number of possible values is infinite, right? And so just keeps going. So the height of randomly selected person from a population, the random variable, let's call it y, can take on any value within the range of human heights, like 150.5 centimeters or 170.3 centimeters. And so the random variable here, whatever randomly is going to be somebody's height in our next event, right? The next thing that we measure, you know, that's going to be random, and that variable is going to be random, and its height and it's continuous versus discrete. An example, the number of heads when flipping a coin 3 times. The random variable, let's call it x, can take on the value 0, 0, 1, 2, or 3. So flipping a coin, the number of heads, the random variable, let's call it x, can take on the number of heads is what we're looking for here, right? So if we flip the coin 3 times, I'm not quite sure. Oh yeah, you could get 0. You can never get any heads. You could get 1 heads. You could get 2 heads, or you could get 3 heads. So that's correct. Corresponding to the number of heads observed. So that's the random variable. It represents some, it's a numerical value that represents some outcome of an event. And so here, the variable is representing the number of heads that you got, right? Did you get 0, 1, 2, or 3? Here, the variable is representing the height, right? The height of a person. And we're randomly selecting somebody, and their height is going to be, you know, random based upon who we select. It's selected. It's just going to be like, okay, what is the height for this one person? And so the variable represents some outcome of an event. And in this example with discrete, it's the number of heads. And in this example of continuous, it's the height. So that's understanding random variables in statistics. Here we have discrete. Discrete could be finite and infinite. And here we have continuous. And again, that's all captured right here in this slide. So example, we'll just explore this a little bit more, but actually let's break this video up and we'll explore in the next video. See you in the next video.